This is Bits and Chips. I am René Rijmakers. In the last episode of my interview with Jonathan Muller, we will talk about the increasing impact of cost in the system engineering equation. ASML and Trumpf approached that requirement from a very different angle. Please note that Jonathan refers to Matthias, who is R&D boss at Trumpf. We will publish that conversation in the coming weeks. What do you like about your job?
Well, there's I think several things to it, but so what I really enjoy a lot is that we have a very young team. So I'm now, with my almost 40 years, one of the older guys. So most people we have in the team, basically we hired from university. Mm-hmm. There's some very experienced guys, but still the average is at well below 35 in R&D, if I'm not mistaken. That is pretty young. Mm-hmm. So that also means that it's quite dynamic. So people adopt quickly. Everybody's motivated. Loves the product also. So I mean, we're building a highly complex system, but people like it. They like to be part of that big environment, being not building so building something that you can see. I mean, it's a huge system, but it's also part of an even bigger ecosystem at ASML, and that is of course a lot of fun to work with those people. And at the same time, we have at least technically, a lot of freedom to do things. So in the meantime, we are, I think, at the stage where even a developer on like working level can make quite impactful design choices. Of course, not without aligning it with anyone. So it's not that everybody goes in any direction, but what they do and what they decide will have impact, mm-hmm. and that creates a lot of energy to the team if they feel that they have this. Because you're in a quite competitive environment. Porsche is here down the road. You have Festo, you have all kind of automotive companies and suppliers nearby. So why do young people choose Trumpf? Yeah, I think it's partially because of this. So compared to automotive also, you have much more freedom here to do things. You have more impact also. So as an engineer, I remember that when I started, basically the first project that I did had a time to market of something like 1 year or so. So basically 1 year after I had started, the first time something that I had designed went to a customer. That is quite impressive. You don't get that easily elsewhere. Yeah. I still like the company. I mean, it's family owned. That also does something. So typically, you also discussed with Matthias, it makes that decisions are more long-term oriented, but it's also that it's more people focused somehow. So you know whom you are working for. You know the people, and you also have a personal connection to them. It's not only you do not work for the numbers, so that somebody gets more revenue on their on their properties or something, but it's really about people, and that makes a connection.
If you talk about engineering choices, cost is a much more important factor now. ASML in the past had to hurry to get to the next node. Now cost awareness is more important. How does that affect your team or your way of working?
Well, I think it's a bit, so another example where similar things happened and that lead to quite some disruptions is aerospace industry. Mm-hmm. So if you take NASA, for example, they have been quite successful for a long time, but at some point what they did was just too expensive, and then companies like SpaceX and or so stepped in with different approaches, also different approaches on system engineering, and took over. And what they did differently is that they were more open towards accepting failure to learn. So they just built a rocket and accepted that it would explode. They just wanted to know when it would explode, and from that data, basically they would learn and build a rocket that just got 1 or 2 steps further, but still not trying to build it first time right, in a sense. And I think that is the key if you talk about cost-effective engineering. then you shouldn't do first time right in the strict sense, otherwise you always over-engineer. So you need to figure out how much over-engineering is healthy, or how much margin, if you want to call it like this, is healthy. But if you overdo it, then it just gets, it works, but it's not cost efficient. And to build cost efficient, you need some level of hardware testing as well at some points to figure out, okay, well here I'm actually not so sure what the requirements is. I don't want to do over-engineering, so I have to test it to figure out to what level I have to actually solve it, and then take the simplest solution that does the job, not one where I'm certain that it does the job. And that is, I think, a key thing, and that's also where we learned already in the past how to do it better. But I think we, and also ASML is, or maybe even ASML more than us, still has to improve in order to build systems that are not over-designed so much as they are today. So by over-design, I mean they're built in margin for good reasons, right? So it's not that it's just plain stupid, but yeah.
But if you have to go back to the drawing table to get it more cost effective, you should actually be able to build it cost effective in the first place.
Yes, but typically it takes some time. So then typically you have to do the loop once more or so, and then it's actually a balance of time to market and being cost effective. And I think there the trend in EUV will be that the balance shifts towards cost, and that the time pressure goes down because we have a working solution, right? So introducing new products is mostly about building products that are more cost effective, so cost per wafer. And that is something where you have to also change your design process somewhat, so putting emphasis on the different topics when you do this design.
ASML wants to have a common platform for low NA, high NA, and in the future hyper NA. Your modules, your systems are more or less ready for that. When did you start with that, and what's the status actually?
Yeah, so we are at the moment introducing a new system generation that is, well, kind of the first module that will be actually identical design-wise for the common platform. So that is very clearly where our new system generation already targets. And basically what you have to do then is already take into account requirements that you don't know for certain yet, right? So when we built the system, or when we designed the new platform, we thought about, okay, what could a, let's say, 50 kilowatts is in the short-term future, but maybe also 70 or 100 kilowatts drive laser look like? And what are then the modules that we want to be able to swap, and what are the modules that we want to keep? So like the base frame, the fundamental aluminum structure that weighs a few tons, where all the power amplifiers are sitting on, that is maybe something that you want to keep. So that should have some margin in how much load it can carry, for example. And you also want to have some margin, for example, on the water connection, that you can also basically supply 20% or so more cooling water, even though you don't know yet where exactly you will need it because you don't have made the full design. And these type of design choices, so building the system sufficiently modular, keeping sufficient margin so that it's likely that to a certain extent you can reuse whole modules of that platform for future developments, that is something that we now took into account for the first time in that way. And I think it's also not so common at ASML that you really design a module not only for one system generation, but also already have in mind, okay, what might change for the next and over next, and so something like 5 or 10 years in the future. What are the requirements or most likely requirements for that system generation, and can we already prepare for this, having the right interfaces and so on?
Does that mean that modules will be upgradable?
Yes. At least the system should be upgradable by swapping modules. I mean, it's then always a question of what you call a module, what you call a system, and so on. But that is the key thing, that you try to build it modular in the sense that you disentangle functional units, and then you only swap or upgrade or change the design of the unit that actually needs to be changed, and all the others you can leave the same as much as possible.
Yeah, but not upgrading modules in the field, that is.
Yeah, most likely. But I mean, we will see. We have done all of this in the past. Yeah, I think that is only future can tell.
Yeah. When Cymer or ASML and Trumpf came together, Cymer of course had a lot of laser knowledge. Trumpf had a lot of laser knowledge. Can you give examples of discussions that were that you were proving?
Yeah. Well, one example is that ASML is always chasing nanometers, right? I mean, that's just their business to ultra precision, so really down to nanometer level. So they are always really eager to get the system stable, and ASML is willing to basically pay whatever the price to improve on accuracy and tolerances and stability. And that does pay off as soon as you get to wafer level. I mean, if you talk about overlay accuracies also, it's incredible what ASML can do, and that is because they are so focused on this. If you build a 10 micron laser like we are doing, then nanometer is not the accuracy range that you need to get in. Typically microns and sometimes even millimeters are sufficient, right? And they are often ASML engineers with their focus on going to nanometers come with let's say, at least from Trumpf perspective, it's not the right mindset on how accurate it actually has to be. And they focus a lot on it must be as stable as possible, where we sometimes say, well, but why do you want to have it better? Actually, like this, yes, it's wiggling around somewhat, but it's good enough, right? It will do the job. So why do you want to be it more controlled, more stable, more precise? And that is what often causes some friction. Also, when it comes to, if you want to go to nanometers, then you really have to go to the textbook and think about how the design actually works, like thermal expansion and so on. If you're in the millimeter range, you can be that's much more forgiving. Yeah. So discussions like, do you need a flexure design or some kind of bearings, or can you just hard bolt it together? How bad is it if you have different materials combined? I mean, of course, if you're chasing for the utmost best precision, then you shouldn't do it. But in some cases, you just can do it, and then you have some tolerances, but you don't care. And that is where often the Trumpf engineers have a much more pragmatic approach than the ASML guys.
In general, you probably can say that German engineers are risk averse, and maybe the Dutch attitude is they are willing to take more calculated risk. Do you agree on that?
Yes, I do. ASML is very risk aware, so they are not risk averse. So maybe German engineers are risk averse. They want to avoid risks, yeah, right? But ASML is willing to take risk, but they do it. They do it in a controlled way. So they want to know what is the risk, what is the probability, what are the options, what happens if, and then they can go for a high risk option if they know very well, okay, I have 70% success rate, I did the business calculation, I have a plan B, let's go there, I'm willing to put the money on the table. Yeah. That type of risk, the ASML is typically very willing to do, but not in an uncontrolled way. So they want to know what is the probability that I'm lucky, what is the probability that I fail, and if I fail, what happens then? So is it then catastrophic, or do I have a plan B and it's basically a choice of business cases? And that's something where I think we as Trumpf, which is more coming from a small company workshop type of setting, we need to learn and did this already, but I think we can still improve on this. So doing also let's say the risk assessment in a better way, really building a business case and so on, do it in a very structured way.
Discussions with ASML can be quite fierce, and often If I look back in history, in the history of ASML and for instance ZEISS, who were of course very early partners, and the stumbling blocks into developments and discussions with ZEISS and ASML, there were often bottlenecks when ZEISS didn't put the cards on the table because of confidentiality, of protecting their IP. And in some cases, when ZEISS was open to discuss its problems, ASML was able to help. I was just curious how the situation, how does that work out with Trumpf and ASML? Is Trumpf always able to openly discuss its challenges or problems?
So it has of course changed over the years. So when we started, it was not so clear that Trumpf would be the partner for CO2 lasers for ASML, right? And then of course there is a point in protecting our IP against ASML so that they cannot use it together with, for example, another supplier. In the meantime, that situation has somewhat changed. So for CO2 lasers, it's pretty unlikely that ASML is willing to invest in building up a second source. So there's a pretty high trust level, and that means if we do IP discussions, typically we can do them with ASML because we have a joint interest, which is to protect our joint business, right? So that is the one company approach that you also discussed with Matthias. And that one company approach typically means we need to check whether we as a team should protect the IP against people outside that team, so like some potential future competitors or people who try to make money from IP processes also, and that is typically the decision, and then you can be pretty pragmatic on who does the patent applications and so on. And we do a lot of joint applications with ASML also.
But can it be a bottleneck? Well, as far as I hear, it isn't a bottleneck, but can it be a bottleneck?
It can be, and it has been in the past, yes, sure. But we are trying to get rid of this, so to avoid it. And that is largely enabled by having some fundamental framework agreements with ASML how we treat IP in a fair way, so that it's perceived as fair treatment from both companies. And since we have that, it has improved a lot.
You already told me that actually the teams are quite lined up. For 10 developers at Trumpf, there are 10 people.
That happened in the past mostly when the trust level was not yet so high. So basically ASML people sometimes redid calculation that our teams had been doing just to make sure that they were right. In the meantime, this has actually changed a bit because the openness has increased. So sometimes we have shared teams where basically ASML and Trumpf developers are just working together with using the same share drive to share their files and so on. So there's just full access to ASML on all data and so on. But typically that results in ASML kind of stepping back and say, okay, if I can see everything, that I don't look at it because I just trust you guys, that you're not hiding anything, right? So that the trust level that has gone up substantially over the last years.
But in that way, it's also easy to imagine that people from both sides sometimes contribute to IP or to patents.
Yes, and we often have projects where we know, okay, well actually for this topic we know someone who at ASML who's very experienced. Let's have that person in the team and just ask ASML to help us, like supporting really as a team member, not as an advisor or something. Really doing their stuff because and it can be both ways.
Jonathan, thanks for the interview and the discussion.
Yeah, thanks for coming over.
Thank you. This was the last part of my conversation with Jonathan Müller. In the coming weeks, we will publish an interview with Matthias Wissert, who is head of R&D at Trumpf. Thanks for watching and listening. Please stay tuned to the Bits&Chips channels.